sulfate, I've got 2 moles of aluminum, right? And then I can go from moles of aluminum into grams of aluminum. And if I go from moles of aluminum to grams of aluminum, that's going to be using, again, the molar mass. Okay, you can use the molar mass both ways, right? To go from grams to moles and from moles to grams. It's a twofer. Anytime you have a conversion factor, it's a twofer. All right, so I start out with 2.57 grams of aluminum sulfate, and I convert that into moles. Molar mass is 342.17. So I go in and I got 1 mole per. How many sig figs should I use? As many as you can get off your periodic table. You can see I'm starting with 3 sig figs. I've got 5 sig figs in my molar mass, so that's sufficient. Then I go in and I convert the moles of aluminum sulfate into moles of aluminum. Got that mole ratio from the chemical compound. All right, so if you don't know your formulas and your names, then you're stuck here at this problem, right? See how that nomenclature plays a role? And then I can go from my moles to my grams. I use 4 sig figs in my molar mass. You could use more if you want. And then when I push the buttons, I see that my grams of aluminum sulfate disappear, my moles of aluminum sulfate disappear, my moles of aluminum disappear, and that gives me the grams. And I am a happy boy when I see that number, because that number is 3 sig figs, and that is a smaller mass than the total mass that's in there too. See much more questions in the chat. What's going on here? No. I think I cracked my screen over the weekend. It's hard to see. Please, folks, I like the comments, but please limit on what's going on. If anything he posts is in class, I put this stuff up after class. Yes, I do. I post the notes in there. Yeah. Okay. Would it be fine just to put 2 moles of aluminum and then start with a 2 to 1 mole of aluminum? You can do whatever you want. I do it so that the units cancel out. Okay. Yeah, and somebody said, Gloria says that the mole ratios don't count as sig figs, right? So when you're doing calculations, mole ratios have no sig figs associated with them, right? They are counting numbers, like I have 2 versus 1, and so those are absolute numbers. So I would like you to follow the method I do that your book uses, and that is to map a problem out and then go through and convert your units, canceling everything out to make sure you get the answer right, okay? All right. Okay, how many oxygen atoms are there in 2.51 grams of chromium-3 acetate? All right, so we'll do another problem similar. So I want to find out how many oxygen atoms are there in 25.1 grams of chromium-3 acetate. Well, I already know my answer is going to be a big number, right? Because numbers of atoms are big when you're talking about something you can hold in your hand. So 25 grams is a mass that you could visualize holding in your hand. First thing you need to do is write down the correct chemical formula. All righty. If you don't know the chemical formula, you can't proceed in the problem. You got to go back to take Chem 4 again. All right. So chromium plus 3 acetate. So -1 takes 3 acetates for every chromium. Okay. There you have it. There's the formula. CrC2H3O2 taken 3 times. Nomenclature is not hard, folks. It's just a matter of putting in the time, getting the flashcards out, and memorizing. I mean, gee Louise, when you think about the nomenclature that comes in biology classes, which a lot of you people take, that stuff is hard. It follows no rhyme or reason. Chemistry nomenclature is very systematic, so there's no excuse not to get your nomenclature down. And believe me, wait till you move on. Other classes, it gets harder. All right, get a sip there. My voice is already gone because it's so crappy out. All right, step 2, calculate the molar mass. All right, I'm going to give them to you. You don't need to worry. So this tells me that for every 1 mole of chromium-3 acetate, there are 229.13 grams. Then we use our friend dimensional analysis to solve the problem. Okay, I'll take grams and convert them into moles. And I'll take those moles and convert them into moles, and then moles into grams, right? So I'll start with the grams of chromium-3 acetate, convert it into moles of chromium-3 acetate. Then using the mole ratio from the formula, I'll find moles of oxygen. And then using Avogadro's number, I go from moles to numbers of atoms, right? So these are little things you need to know how to do. If I say grams to moles, what comes to mind is molar mass. If I say moles to moles, what comes to mind is a mole ratio from a chemical formula. All right. If I say moles to atoms, what comes to mind is Avogadro's number. Those are the little bits that you have to be able to string together in calculations to get the problem solved. So I got 25.1 grams of chromium-3 acetate, and my molar mass is 229.13 grams for every 1 mole. So there I have my grams and my moles there. And then from the formula, I know that there are 6 moles of oxygen for every 1 mole of chromium-3 acetate. Remember, if you've got the mole ratios, right, 3 and then 2, so 2 times 3 equals 6, put the calculator down, right? And then Avogadro's number is 6.022 times 10 to the 23rd oxygen atoms for every 1 mole of oxygen. right? So you can see that your units cancel out. Grams are gone, moles are gone, moles are gone, moles of oxygen are gone, and you're left with numbers of atoms. Must have done the problem right. Push the buttons on the calculator, and I get a big old hunking number, and there's 3 sig figs in the calculation, okay? Does that make sense? See how these things work? Little bits, steps like this. These are things that you should have down 1, 2, 3, 4. And you'll be getting more practice in your homework on stuff like this for next week's homework is coming up, okay? Grams to moles is molar mass. What are the other 2 things I remember? Mole ratios, Avogadro's number. Okay, that's for Elizabeth there, okay? Moles to atoms give us, are done through Avogadro's number, right? Remember, it's all about the conversion factors. That's all we do here right now. All our calculations are based on doing conversion factors and using dimensional analysis, okay? You need practice, don't worry. You're gonna have some homework on this coming up. You're gonna see some of the worksheets I've got there. And next week in discussion, we'll be doing gram and mole calculations like this, okay? So we'll be reviewing that in discussion. Okay, how many grams of chromium then are there in 25.1 grams of chromium 3 acetate? Well, I know that it's going to be less than 25.1 because chromium makes up only a part of the whole compound, right? Mm-hmm. So again, this is just another series of calculations where we're going to go through grams and moles and back to grams now. Okay, simple example. These types of calculations should be very straightforward and simple, especially if you took Chem 4. Mm-hmm. Okay, so chromium 3 acetate has a molar mass of 229.13 grams per mole. Okay, again, I'll give you your molar masses, so don't worry about it. So I'm going to go from grams of chromium 3 acetate to moles of chromium 3 acetate to moles of chromium, and then from moles of chromium into grams of chromium. Right? Same thing before. These calculations are simple little parts of bigger things that we'll go through down the road. All right. So grams to moles using molar mass, mole to mole from the mole ratio, and moles grams using molar mass. Those are the things that we know. So if you've got 25.1 grams of chromium 3 acetate and the molar mass says that there's 229.13 grams for every 1 mole, you can convert those grams into moles. I like doing this. I still do it this way. Okay, I've been in the front of the classroom teaching chemistry for over 25 years. When you come into my office, if you're looking at scratch paper while I'm working through problems and things, I write down my units. All right, I don't like making mistakes because if you try to do it without writing down your units, you can invert a conversion factor and you get a funky answer, okay? So then from the formula, I know there's 1 mole of chromium for every 1 mole of chromium 3 acetate. Again, if I don't know my nomenclature, I can't do this problem correctly. All right, and then I know for every 1 mole of chromium, there's 52.00 grams of chromium. Remember, there's no sig figs associated with mole ratios. Okay, they're absolute numbers. They're counting numbers. Anytime you have a counting number, 1, 2, 3, 4, 5, 12, those numbers do not carry sig figs because they are exact, okay? And I push buttons on my calculator, and I get a number that's 5.70 grams of chromium, and I like that number because it is less than the total mass, and I started with 3 sig figs, and I ended up with 3 sig figs, okay? All right, so these calculations and these things are stuff that's supposed to be bing, bang, boom, real quick. These are going to be parts of bigger problems as we go down the road. You'll see this when you get onto other chemistry classes. When you get to Chem 1B, they're going to expect you to be able to do calculations like this, snap, snap. Even in organic chemistry, right? You're going to need to see that. Whichever. Thank you. Okay. If using diatomic, I'll bring up that. Tatum answered the question. If it's O or O2, I'll bring up an example of that coming up. Yep. So thank you, Tatum, for answering that question. Mm-hmm. All righty. I want you taking all the stuff we've done to answer the following question, right? Think about this in terms of grams, moles, mole ratios, okay? So how many grams of calcium chloride contain the same moles of chlorine that are in 2.5 grams of sodium chloride, right? So let's say I start with 2.5 grams of sodium chloride. Well, if I know the molar mass of sodium chloride, I can figure out the moles of sodium chloride, which then tell me the moles of chlorine, right? And then if I look at the formula for calcium chloride, I know how many moles of chlorine there are for every 1 mole of calcium chloride, which then, if I know the moles of calcium chloride, I can get the grams, right? So I want you to see if you can figure this out. Okay, useful information that you might need to answer this question is the molar mass of sodium chloride, which happens to be 58.44 grams per mole, and then the molar mass for calcium chloride, which happens to be 110.98 grams per mole, okay? So I want you to try to do this on your own. All right, think about this. You want to go from grams of sodium chloride to grams of calcium chloride via chlorine, based on using the molar mass of the compounds and the mole ratios. All right, so think about it. Okie dokie. So think about this, right? If I start with grams of sodium chloride, then I can convert that into moles using molar mass, right? And if I know that I have 1 mole of sodium chloride, I have 1 mole of chlorine from the mole ratio. And then if I know moles of chlorine that came from sodium chloride, there are 2 moles of chlorine for every 1 mole of calcium chloride, which gets me into moles of calcium chloride. And if I know the molar mass of calcium chloride, then I can get the grams of calcium chloride. And you should have got, as an answer, 2.43 grams of calcium chloride, right? So let's just think about this. Just knowing what we know about chemical compounds in terms of molar mass and mole ratios, we should start out with grams of sodium chloride. Molar mass of sodium chloride is 58.44 grams per mole. So I convert those grams into moles. Good. All right. That's what molar mass does for us. It takes us from grams to moles, or from moles back into grams. Then I know that for every 1 mole of sodium chloride, there's 1 mole of chlorine. That comes from the mole ratio, 1-to-1 in this particular case. Right? Sodium's +1, chlorine's -1. All right, good. Now I know from the formula for calcium chloride that there are 2 moles of chlorine for every 1 mole of calcium chloride. That's the definition of the formula. I see. Right. So now, if I know the moles of chlorine associated with sodium chloride, then I could use those moles to tell me how many moles of calcium chloride would correspond to the same number of moles of chlorine. 2 moles for every 1 mole of the compound, and then using the molar mass, I can convert into grams. So 1 mole of calcium chloride has 110.98 grams. And there you have it. Okay. This works out because the units work out, right? Now look at the solution to the problem. Very simple, right? A series of multiplications and divisions. However, you have to think your way through it using what you know, and that is mole ratios from chemical compounds, molar masses taking us from grams to moles and moles back to grams, all right? So chemistry problems themselves, the solution is simple. The setup is the hard part, thinking about all the stuff you know, okay? All right? So what looked like a very impossible problem is actually quite simple. It's a series of multiplication and division steps using the things you know. Okay, dokie. See how that works? Okay, good. That's the end of chapter 2. Let's get into chapter 3. Okay, so we're going to talk a little bit about chemical bonds just in general. We're going to define types of compounds, and you need to be able to differentiate between chemical compounds, right? If I point at a compound, you got to tell me what kind of compound it is. Is it molecular or is it an ionic compound? We're going to talk about chemical formulas in their meetings. We've already done that somewhat. And then chemical nomenclature. All right, that's something you have to be working on outside on your own. Flashcards, worksheets. Okay, PAL people are working on nomenclature. You're going to see more of it show up in your homework. I may even throw an extra worksheet into your homework for some stuff. Remember, we're not covering nomenclature explicitly in class. I've got tons and tons of stuff up there for you. But if you're not working on it, you better get a move on it. Basically, by the end of the third week, if you don't know your nomenclature, the likelihood of success is very, very dismal. I have numbers that show that. It doesn't mean that you're going to die, but it means you're going to have to go in and catch up real fast on your nomenclature. You have your nomenclature proficiency quiz next week, which will tell you if you're on track or if you need to start working harder on your nomenclature. Then we're going to use information to determine chemical formulas. We'll do things like the percent composition